Hello, everyone. I hope you had a nice week last week. I just want to remind you, before we move to the next unit, what we covered last week. We talked about phenotype versus genotype. Remember, genotype is the actual alleles that are inherited, the actual letters, whereas phenotype is what we see. So what results, what appearance occurs, or what trait is inherited because of the combination of these genes. So this is giving you an example of phenotype being a smooth seed. That would be one phenotype. And remember, with that, you can have two different genotypes. You could have the big S, or a big S, little s, because smooth seed is dominant, or a wrinkle, little s. So two phenotypes, wrinkle versus smooth. And then the genotype are the actual alleles. Because the wrinkle is recessive, you would have two little s's in order to express that trait. Now, if all of this is very foreign, I would encourage you to go back and listen to the lectures from last week. All right, I'm going to go ahead and skip this. This is just dealing with a pedigree chart, which we're actually not going to go over this year. So probability. When we draw Punnett squares, what we're really doing, and I don't know if you remember this, way back from Mr. Bates's days in 8th grade, I think is when you go over it, you talk about a bunch of Punnett squares and genetics, and I want to go ahead and put a disclaimer. At your level, it is very hard to talk about genetics accurately. Genetics, there's a lot that goes into play with the genes that you inherit. And it's not going to be as simple as the Mendelian traits that we've talked about, where one is dominant over another. But some traits do follow this. So we are going to assume they all do as we navigate our way through the introduction waters of genetics. So probability is the idea that this shouldn't be a new word to you. The chance that the outcome of any given event will occur is proportional to the number of ways that event can be reached. Now, that's a lot of words, and what the heck does that mean? Well, let's just put it into layman terms. If you flip a coin, you have a 50-50 shot of getting heads or tails. So here's my handy dandy coin. This is a quarter, so now we've got it a little more confusing because it's, I don't know, the strange tail side that's actually a state, or this is San Antonio Mission, so this must be the Texas one. But then you have over here the heads. So you have two options. You could get heads or you could get tails when you flip a coin. It's always going to be 50-50. Now, if I flip my coin and it lands on heads once, does that mean that it's not? If I flip it again, do I have more or less of a chance of getting heads? So I flipped it, boop, 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 boop. It landed on heads. I'm going to flip it again, boop, 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 boop. And what's the chances it's going to land on heads again? It's still 50-50 because it resets itself, okay? The genes that occur in your body and the alleles, your parents always bring two different sets, right? One from mom and one from dad. So it's a lot like this coin. And the worksheet that you're going to do today is going to kind of compare, act as if these were mom's genes, heads and tails, and she was a heterozygote. She got a big R and a little r. And these were dad's genes, and he got a big R and a little r. Okay? And that's what we're really looking at, is the probability or the chances of these guys combining. What if they have these genes, big R, little r, and dad has a big R and a little r? What are the chances of that their babies will have two big R's, a big R and a little r, a big R and a little r, and a little r and a little r? So we're going to talk about this. All right. This little word right here, you do need to know for your test, just Mendel's law of segregation. It's so fancy and scary looking, but it's just basically saying that go back to when chromosomes line up and they undergo meiosis. Basically, if this was mom, she had a big A. Well, this was grandma's genes, and this was grandpa's genes with the little a. During meiosis, in metaphase, they line up, and basically the two alleles are going to separate to go into the egg or the sperm, right? So let's say this was a mom. Her two alleles will separate, one into here and one into here, okay? Now, upon fertilization, mom's egg will combine with dad's sperm, okay? Again, this is a word that you've got to know. Heterozygotes organisms are called hybrids. Just a reminder of a vocab word. All right, so this is just showing you Mendel's law of segregation again. But what you want to know about Mendel's law of segregation is this is an example of the Punnett square. This is why we set it up. So let's say this is a blue beetle right here. Everybody see this blue beetle. And he had a big B and a little b, because obviously blue is dominant. All right, so this beetle had two different alleles that it could give. It could give a big B or it could give a little b. And this beetle, which was the mama beetle, had two little b's. So she could only give a little b or a little b. Now notice the parent's genotype goes on the outsides of these Punnett squares, okay? And then we fill it in. And I'm going to talk more about Punnett squares in the next lecture. I want you to do this probability coin flipping before we go into Punnett squares in too much detail. But basically, all of the big B's, dad's sperm, go over across. And all of his little b's go across. And all of her little b's go down. And all of her little b's go down. So this is showing you we have a 50-50 shot of getting a heterozygote blue beetle and a 50% shot of getting a homozygote green beetle, okay? And this is what the Mendel's law of segregation says, that basically these alleles will separate. So this is showing you dad's alleles for this trait of beetle color separate when they go and make their little sperm, and mom's eggs, the alleles for making the green beetle color, separate when they make her eggs. But upon fertilization, they come back together and they get their homologous chromosome, okay? So before I start talking more about Punnett squares, but I do want to just show you this because there is something in your worksheet that deals with this. But basically, Punnett squares will predict how this mom and this dad will combine to make what type of genotype and phenotype babies. Of the parents' alleles go on the outside of these Punnett squares, and then they combine. All of this would be mom's go across. So it's big T goes across, and her little t's go across, and these are dads, they go down. Big T goes down, little t goes down. Now it doesn't matter. The big thing is that you put all of dad's on one side and all of mom's on one side, but it doesn't matter which side you go to. Now I'm going to go into much more detail about that. What I'd like for you to do now is just get familiar with this idea of probability and chance. And go ahead and open the worksheet up. If you have questions and you're confused, I have a quick lecture that just talks in a little more detail about the worksheet and what we're talking about with coin toss that you're welcome to listen to.